Okay, let's move on and talk about some more specific characteristics of the distribution of our data that we want to be able to come up with from our dot plot. So the distribution shape is one of the most important characteristics we will assess of our data. The importance of the shape is actually going to carry us through all the way to the end of the semester when we're working on our inferential statistics, estimating population values, conducting hypothesis tests about our population values. The shape of the distribution of our data can come into play and play a critical role in our data analysis, so that this really is something that will carry forward. Okay, in each of these two shapes, the commonality is that we've got a lot of data on one side and then a little bit of data on the other. In our dot plot or in many of the other kind of graphs, we're going to look at how high your dots or your bars are, is indicating how much data you have there. So the further up that stack of dots goes, the more data that we have. And notice I'm not getting too hung up in variations. I'm not going to very strictly sort of bop up and down at this data. In statistics, we're really kind of standing back, squinting a little bit, and just getting an overall feel for the general pattern of the data and not getting bogged down in any fine details. So any shape like this, where you have a lot of data on one side and a little data pulled out to the other side, is when we describe that distribution as skewed. The distribution also could be if it just starts very high and then goes down to the side. That would also be skewed. The direction that you give to your skewness is also sometimes counterintuitive to how students would like to describe it. Although the bulk of data for this one is on the left, the direction that we give to the skewness is to the side that is pulled out. So this top picture would be described as skewed right, as would this picture that I drew down here. That would also be skewed right. And then this picture here is skewed left. The side with a little bit of data pulled away from the rest, that is the direction that you give to your skewness. Each of these pictures are exhibiting a central peak, although they're certainly very different. The bottom one, the sides are pulled out a great sort of a great distance from the peak, and in the one on the top, well, actually I drew that out a lot farther on the side than it goes, right? It actually just stops very abruptly right there. But in either case, we would identify these as a bell shape. Fairly symmetric. It does not have to be exact like it does in algebra class. Symmetry here is just, draw a line down the center, and the two sides look a lot alike. They don't have to be identical, but they're a lot alike. One central peak pulled out on either side, a little or a lot. That's our bell shape. This last one down here, again, although it technically has some peaks and some valleys, if we don't get bogged down in those little variations, this one essentially just goes straight across. So this is an example of a uniform distribution. So when all of those outcomes are coming out around the same amount, that's when we have this uniform distribution. Okay, let's take a look at this learn by doing activity I have here that goes along with page 31 in OLI. They want us to pick out the variable that best represents the shape of this distribution. So first off, let's examine the shape of this distribution. We have a lot of very high data. We've got a little bit of that data pulled out to the left. So this would be a skewed left distribution. Would that match repeated volume measurements of a 1 liter bottle of soda? Well, I don't think that matches at all, right? This part might match the volume of the soda bottle, but when you look on the shelves, we don't have noticeable bottles with very much less volume. So that doesn't match. Salaries of New York Yankees. Well, baseball salaries, like most everybody else's salary, in fact, matches a skewed right distribution. There will be a lot of data with salaries at the very low end of the scale. If you're a baseball fan, think of all those guys on the team that like you never even see because they hardly get to play. All of their salaries are down here, and then you would have a few very star athletes with a salary in the high end. So salaries do not match this distribution. Quiz scores on a very easy quiz. So lots of grades that are very high, and well, then a few folks that just did not catch on to that material and they've got a low score. But this one matches the skewed left distribution that we have been given.